Algebra with Algebra Tiles. I am Patrick, and I will teach you how to do algebra with Algebra Tiles. Speak. Say something. Say something. All right, that kind of didn't work. Enjoying your coffee? So we are going to get into doing algebra again, using this time algebra tiles. As you remember, last time we looked at algebra and the balanced scales, which took a look at really what that equal sign meant. So today, here is my algebraic equation, which of course is shown here as well. And I'm going to solve this in both ways using algebra and using the algebra tiles. But the first thing I'm going to do is kind of ignore this algebra strategy, and I'm just going to stick with the tiles. But looking over here, once again, I am going to go through the process. So the first thing I do is simplify the like terms, which means group all the like terms together. Well, visually, you can see what the like terms look like. Well, I already have these variable blocks already put together, and I got these constant unit blocks put together. On this side of the equal sign, I got my variable blocks put together in a group, and I got my negative blocks in a group. So they're already simplified. They're already grouped together. So that's done. I'll put a little check mark here if Patrick will let me. Move my hand over there, my son. Check. Second part is decide on a variable side. Now, if you remember with that balance scale, I don't know if I really explained it well because it was hard when you have an example where only one side of equal signs got variables. This time around, if you both sides of your equal sign, and again, I'll actually look at the equation here, both sides of your equal sign, so here's your equal sign, both sides have variables. So you need to avoid ending up with a negative x in the end. You want to decide what side you're going to represent your variables and what side of the equal sign will be for your constants. And you always want to choose the side that has the more variables in it to avoid negatives in the end, which requires you to do an extra step. But I like to avoid extra steps. So this side here is going to be my variable side, and this side here will be my constant side. Right, Patrick? Say something. Say something. My son, say something. There, you're all quiet now. Oh, there you go. Anyway, where am I? Okay, so this is my variable side. So because these are variables, I have to get rid of these three negatives. So to do that, if you remember using algebra tiles, you want to create zero pairs in order to get rid of them. So what I'm going to do is add 1, 2, and 3 positive blocks here. And because I have the 3 positives joined up with the 3 negatives, that equals 0. Those are 0 pairs, and now I can eliminate them. And if you need a review on that, you can go back and take a look at the videos done with solving expressions in algebra. Don't tip over the coffee! Just joking. So now those are eliminated, but because I added 3 positives, you have to maintain balance in your equation, so you also have to add 3 positives to the other side of the equal sign, or else they're not in balance. Now that all I have on this side of the equal sign are variables, I look at this side, and this is my constant side. I got variables here that I actually have to get rid of. You do the same thing. So I'm going to add 2 0 pairs to create, well, 0 pairs to get rid of. So I take out those, but again, because I added two negative x tiles, I have to add two negative x tiles over here as well to maintain balance. And I will get rid of those. Those become 0 pairs. And now I'm left with a very cool situation. I'm just going to bring these down here into my next section. Where's my assistant gone? So now I got 6, and I'll bring what I have left here down. Now I have 6 equals 2. Well, guess what? I have now almost completed, well, I've done this, decided on the variable side. I've almost completed isolating the variables, but I still have 2x equals 6. I want to find out what 1x equals. So therefore, I need to now, I mean, if you go over in algebra, you'd be dividing, but in algebra tiles, you essentially put them in groups, which is what dividing is. So there's my two groups, and I will just separate or divide up these blocks into two groups as well. And there you have it. So 1x equals 3. And there's my final answer, x equals positive 3. And that's algebra tiles. All right, now going over just straightforward algebra, and I like to maybe, if I can, whenever, make the connection with the tiles. So simplifying the like terms. There's no like terms here. You have variable, you have constant. You have variable, you have constant. Simplifying is already done, just like what I mentioned over using the tiles. Decide on a variable side. Well, this side here has more variables, so that'll be my variable side, and this will be for constants. So because this is variables, I want to get rid of negative 3, and to do that, you'd use opposite operations, which is simply adding 3. So for x minus 3 plus 3, this would be 0. But again, to maintain balance, I also have to add the 3 here. Now, if you notice, adding 3 in algebra means adding 3 right here, 0 pairs. So whenever using opposite operations, essentially using algebra tiles, you are adding 0 pairs. So if I were just to simplify this now, I will end up with 2x, 3 and 3 is 6, and this is equal to 0, so I'm left with 4x here. Now again, this is for variables, this is for constants. I got 2x here I got to get rid of, so I'm going to do the same thing, which is what I did here, if you recall. Right there, I added 2 negatives to create 2 0 pairs, which is what I'm going to do here. Except I'm not going to add tiles, I'm just going to say 2x. Opposite operations means 2 minus 2x, as I want this to equal 0. I got to get rid of these variables. Plus, I'll erase this here. Plus 6 equals 4x. But because I subtracted 2x, I have to subtract 2x here as well. So now I'm left with 6 units equals 4x minus 2x. Is 2x, and that is what I have here. So now my last step in isolating the variable is to divide by 2. Since that's multiplying by 2, the opposite is divide by 2, and I'm left with 3. So there you have it. There is the connection between algebra tiles and straight algebra. 0 pairs is essentially isolating the variable using opposite operations. Where's my assistant? St. Patty, you want to say, this is my little enforcer, by the way, in case you don't know. Let's say goodbye. Now you're talkative. Say goodbye to all the math peeps out there. Bye. 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 Yeah, there you go. Bye-bye.